In this lesson, we're going to learn about differential equations. A differential equation is any equation which contains derivatives, either ordinary derivative or partial derivative of one variable with respect to the other. So that's what a differential equation is. And in the definition, you see that what you have what ordinary derivative and then partial derivative. In my next video, we are going to learn more about these two types of what derivatives. And also, we are going to learn about the two types of variables in differential equations, which is what the dependent and then the independent variables. Okay, so we know that what a differential equation is any equation that contains what a derivative. Okay, so for us to be able to identify a differential equation, we will have to know what a derivative is. Okay, so we are going to learn how the forms of what the derivative of a function can be. Okay, so that when we see one, we will be able to know that what this is a derivative, and therefore when we see an equation which is what a differential equation, we will be able to what know. So let's have a function f of x which is equal to what y. Okay, the first derivative of this function will what the f of x over the x. Okay, and this will be the same as what dy over the x, and then this will be the same as what f prime of what x, and then also the same as what y prime. So all these expressions that are written here are different forms of what the first derivative of the function f of x. So let's write the second derivative of the function f of x also. So that will be d squared f of x, okay, over the x squared. This will be the same as what d squared y over the x squared, and then that will be equal to what f prime prime of x, and then it will be the same as what y prime prime. Okay, so these are the different forms that you can write the second derivative of the function f of x in. So in general, we can see that what the n derivative of the function f of x is what d to the power n f of x over the x to the power of n, or d to the power ny over the x to the power of n, or fn of what x. So all these are the different forms that you can write the nth derivative of a function in. Okay, so let's take an example. Okay, so I'm going to look at what an example of what of a differential equation. Okay, so I have the first example here. Okay, so which is what a multiplying the second derivative of the function f of x plus b multiplying the first derivative of the function f of x, and then plus c multiplying what f of x equals what g of t. A, b, and c here are what constants. Okay, or they are the coefficients of what the derivative of the function what f of x. So from the knowledge we have here, okay, you start what we can write this differential equation here what, in different form. Okay, so let's look at how you are going to do that. So we can write this as a y prime prime plus b y prime plus cy equals what g of what t. Okay, this is also what a different form of what this differential equation here. And then from the definition of a differential equation, we know that what any equation that contains derivatives of what of a function is what is a differential equation. And then looking at this equation here, it contains the derivative of the function f of x with respect to what x, and then there's another derivative here, and then the function itself is here. So it's that what this equation here what contains what the derivative of the function f of x with what respect to what x. So therefore it is a differential equation. And then looking at this side here also, we have written it what in a different form. Okay, so that's also what a differential equation. We can rewrite this also as what a f prime prime of x, okay, plus b f prime of x, okay, plus c f of what x. This will be equal to what g of t. This is also what a different form of what this differential equation that you have here. So now you see that what knowing the different form that the derivative of a function can be written in is what is very important. So please take note of what you have here. So let's take some few more examples to help us what know how to identify what differential equations. Okay, so the second example here is a equals v over t. Okay, this is also what a differential equation because it has what the derivative of what v with respect to what t. And we know any equation that contains a derivative is a differential equation. So what you have here is also what a differential equation. So let's take note of this. The v here is what velocity, t here is time, a here is acceleration. Okay, so let's take note of this. So what you have here is also what a differential equation. So the third example, v equals dx over dt. This is also what a differential equation because it contains the derivative of what x with respect to what t. Okay, so this is also what a differential equation. So x here represents displacement. Okay, so what you have here is also what a differential equation, which is what it contains what a derivative. So let's look at the fourth example. So that's F equals what ma, which is what force equals what mass times acceleration from what Newton's second law of what motion. Looking at this equation here, we can't tell directly that what it is a differential equation. So how are you going to do this to prove that what it is a differential equation? Okay, so for us to be able to prove that what force equals what mass times acceleration is a differential equation, let's follow the following steps. So from example 2, you know that what a equals what dv over what dt. So you can substitute a back into what this formula. So we now have what f to be equal to what f to be equal to okay, m dv over what dt, right? So this now becomes what a differential equation because we now have what the derivative of v with respect to t in this equation. So this is also what a differential equation. So therefore we can tell that what the equation for Newton's second law of motion is also what a differential equation. Okay, so you can write what I have here, okay, in a different form. Okay, so we know that what v equals dx over dt, okay, and then a equals what dv over what dt. So you can substitute the value of what v here in place of what this v here. So you therefore have what a to be equal to d of dx over what dt, okay, all about dt. So let's look at what that means. So you have a to be equal to what? So looking at this square bracket here, you are going to take what the derivative of x with respect to what t. Okay, so that what the first derivative of what x with respect to what t. Then after doing that, we will take the derivative again, okay, which is what the derivative of what the first derivative of x. So that will give us what the second derivative of x. So therefore, you have what a to be equal to what d squared x over what dt squared. So that's the value of what a now because what you have taken what the derivative of what this x here with respect to t two times. So we now have what a to be equal to what the second derivative of what x with respect to what t. So from here we can substitute this into f equals what ma, right? So that will be f equals m multiplying what d squared x over dt squared. So this is also what a differential equation because what it contains the second derivative of what x with respect to what t. So this is another form that we can express the equation for Newton's second law of motion. So these two equations here tells us that what the equation for Newton's second law of motion is a differential equation. Okay, so what I have here on the screen here are more examples of what differential equation. So when I look at these examples here, for example one, we have what the derivative of what y with respect to what t. So since it has what a derivative in it, it is a differential equation. With example two also, we have what the derivative of what r with respect to what t. Okay, that's also what a derivative. So that makes this equation also what a differential equation. And then example 3 also, you have what the second derivative of y with respect to x. That's also what a derivative. And any equation that contains a derivative is a differential equation. Same here, you have what the second derivative of I with respect to t, the first derivative of I with respect to t. So this is also what a differential equation. Thank you very much for watching this video. Please make sure you subscribe and then turn on the notification bell so that when I release new videos for this course, you will be notified. Thank you.